exactly one termination, it equals to mu lambda, mu del t. And third one is the probability of no arrival equals to 1 minus lambda del t. We have the probability of exactly one arrival which is equals to lambda del t. So if we find out the probability of no arrival which is equals to 1 minus lambda del t, which is related to this. And the next similarly probability of no termination will also equals to 1 minus mu del t. So similarly there are four particular probabilities we already find out with the help of time interval del t. Now the probability of, by these assumptions, now we find out the probability of finding the system in state k at time t plus del t. The probability of finding the, as per the birth death process, as per the particular figure, as per the figure, after time t plus del t, earlier the time is t, we have the state k plus 1, k and k minus 1. After time del t, if death occurs, if no change, if birth occurs, we are we will go to the state k. So after time del t, what is the probability of reaching reach the particular state k, which we have to find out. So after probability of finding the system in state k at time t plus del t, p k t plus del t, it means the probability of finding the system in state k at time t plus del t. That means at time t plus del t, the probability of finding the system is in state k. So there are three cases. With the help of with the help of three cases, the state transitions occur and we will reach to state k. So first of all, the first term we will then the first particular term come, first particular state transition occur because of this particular birth phenomena. So in case of this particular birth, whenever the birth occur, earlier at time t, the particular state is k minus 1. Earlier at time t, the state is k minus 1, and the particular arrival rate, or we can say the birth rate or arrival rate, which is denoted by lambda. So at particular state k minus 1, the particular birth rate or arrival rate is lambda k minus 1. So the particular pkt plus del t equals to pk minus 1 t. At time t, the particular system is in state k minus 1 and the birth occurs, so that's why the birth rate is, or we can say that arrival rate is lambda k minus 1, because at state k minus 1 the arrival rate is lambda k minus 1 and that particular duration is del t. So this is the particular term represent to birth. Plus now the second thing, whenever the particular earlier the system at t at time t is in state k plus 1 and the termination occur, or we can say that a death occur. So that for that particular death term is represented by p k plus 1 t mu k plus 1 del t. This is for death. This is for birth, it means for arrival. It is for death means termination. And the third one is plus when no death, no birth occurs. It means there is no arrival or no and no death. So it can be represented by 1 minus and the state is remains same. So the state is k. So 1 minus lambda k del t multiply by 1 minus mu k del t and pk. So this is the express. So this is the expression for the probability of finding the system is in state k at time t plus del t. It is for no change. It means no arrival or no termination, or we can also say no birth or no death. Now we expanding this particular expression. So whenever we go for expand, then pkt plus del t equals to pk minus 1 t lambda k minus 1 del t plus pk plus 1 t mu k plus 1 del t plus pkt bracket. Now we multiply these particular terms, then we have pkt multiplied by 1 minus mu k del t minus lambda k del t plus mu k lambda k del t square. So now ignoring this particular term, which is second order del t term. So now second order del t term. So now the expression we get pkt plus del t equals to pk minus 1 t lambda k minus 1 del t plus pk plus 1 t mu k plus 1 del t minus lambda k plus mu k pkt del t. So now the expression we get pkt plus del t equals to this. Now there are some arrangements, or we can change the places of some terms. So pkt plus del t minus pkt upon delta t equals to here another term is pkt. So this term comes here, this side to this side, upon del t is common in each term, so it comes upon. So equals to pk minus 1 t lambda k minus 1 plus pk plus 1 t mu k plus 1 minus lambda k plus mu k pk t. So if the limit del t tends to 0, then we get, now we applying limit. So if limit del t tends to 0, then dpkt upon dt equals to pk minus 1 t lambda k minus 1 plus pk plus 1 t mu k plus 1 minus lambda k plus mu k pk t. This is our expression. dpkt upon dt equals to pk minus 1 t lambda k minus 1 plus pk plus 1 t mu k plus 1 minus this. So this our first expression for dynamics, for governing the dynamics of a birth death process. So what this is our main expression. This particular equation satisfied only for whenever the value of k is always be greater than equal to 1. So this particular equation only satisfied for these conditions. If k equals to 0, if k equals to 0, then if k equals to 0, if we put k equals to 0 in this equation, then here the value is p0 minus 1 t lambda 0 minus 1. So it means there is a state have the value minus 1, which can't be possible. No state, no state or no population mentioned in terms of minus 1. First thing. And second thing is that whenever k equals to 0, the mu naught equals to, whenever so k equals to 0, it means if k equals to 0, first thing is that there can be no state with minus 1, and the second thing is there can be no termination of call. So mu naught equals to 0. Mu naught equals to 0. If k mu naught equals to here, if k equals to 0, then it means it is if k equals to 0, there are two things. First thing is that here p0 minus 1 t, it means there is a minus 1 state, which can't be possible. And second thing is that there is the value is mu 0. It means the state where no population. If there is a state there is no population, then how can be a death occur? So it also equals to 0. So mu naught equals to 0, and this state can't be possible. So now the expression for at k equals to 0, dp naught t upon dt equals to p1 t mu 1 minus lambda naught p naught t. This is the particular expression when it is second equation and it is numbered as 1 and this one numbered as 2. This expression for k equals to 0. So we have two particular equations. First for k is greater than equal to 1, and then second one is k equals to 0. Both are the particular BD process equations. Now further we will discuss about the BD process under steady state condition. Now we will discuss about the birth death process